An important question for this video: can P2S replace X1 carbon? Looking at the specifications and the price, yes, but let's see how it prints. Welcome to my tech fun, to another Bambu Lab 3D printer review video. This is P2S, and another printer which I got before the premiere. And this box is sent to me by Bambu Lab in exchange for the review. There is no additional payment from their side, but this video and the whole channel is sponsored by Polymaker. The build volume of this printer is 256 mm in X, Y and Z direction, and the maximum nozzle temperature is 300 degrees Celsius, so no change in scale compared to the P1S. But now there are improvements: hardened steel nozzle and extruder by default. If you're not familiar, the P1S, if you want to print carbon fiber filaments, you had to upgrade the extruder and the nozzle to the hardened steel or similar materials, but here it is included by default. Dynasize extruder with the quick step nozzle, which is compatible with H2D series, but not with the A1. And now the most important upgrade: 5-inch touchscreen. I think this was the most important motivation for the buyers to buy X1 Carbon instead of the P1S. There are some attempts by companies to create some kind of third-party screen, but the communication with the printer is limited. Additionally, we have now the 1080p high frame rate camera, AMS2 Pro, which is able to dry the filament only not during the printing but before the printing, autoflow dynamic calibration, no active chamber heating, but it can regulate the temperature by switching between the internal and external air circulation. Watching these specifications, I cannot really see advantage of the X1 Carbon compared to the P2S. I'm not sure about the prices. I'm recording this much earlier. Who knows, maybe we will see soon X2 Carbon with, I don't know, 350 degrees Celsius on the nozzle, actively heat the chamber. I'm just guessing. I don't have any additional information except this which I mentioned already. Probably by now you already watched few review videos from very popular channels, so in my case I will do my testing which I'm most curious about. Don't worry, I will test it with the multicolor PLA2 with a lot of fixed materials. I know this is always the request, but most important for me is to see if it can handle those brittle carbon fiber filaments too. Let's see what's in the box. There are a few things which I can take out only when the bed will be lifted. This has to be taken out too. I think it's here. Quick look into the AMS2 Pro. So the AMS2 Pro, it can even dry the filament, but not during the printing, but before printing. These inlets are ceramic, so they will not wear out, because there are still some carbon fiber filaments which can go into the AMS. And another big improvement is these Teflon tubes are visible now. In case we have some broken filament inside, it is much easier to disassemble it compared to the first version. Before I place the AMS on the top, let's take a closer look inside. I can see them move to the metallic rods now. Okay, this is the extruder Teflon tube, and I can see quite a lot of bending of this Teflon tube in edge position. I'm curious if it can handle brittle filaments like carbon fiber, I don't know, PPA or similar. I can see some mounting holes on the other side, but I'm not sure what are they for. Maybe some chamber heater upgrade in the future. We will see. Okay, again very weak LED only on one side. It would be good to have something from the front too. Oh, actually, now I notice that maybe we do have the light on the front panel too. I will check this, of course, when I turn it on. And this is the back side of the printer, input for the filament, and I cannot see the ventilation holes. I don't think it's this one. On X1 Carbon it was here, and it is connected to the ventilation hole on my wall for printing ABS and similar filaments, because this is just a ventilation for the electronics. This is the opening for the filter and ventilation, But where does it go? To the side? Okay, so far it's a mystery for me. Maybe on the bottom, because no holes on these sides. I will explain it later. This is only the input for the cooling air. Not sure if you can see it, but the distance between the Teflon tube and the top glass is very minimized. Come on, Bambu, don't do the same mistake like those cheap printers. Installing the AMS is very simple, just one cable and a Teflon tube. Only pay attention here, it has to go quite deep. Press it a little bit and then try to press it as deep as much as possible, at least 20 mm or so. External spool holder if you don't want to use the AMS, and it goes to the right side of the printer. Another confusing thing. External spool holder. I want to use it with some brittle filaments which cannot go into the AMS, and theoretically the filament bed from the external spool holder goes into the filament buffer and then do 180-degree turn, inside another 180-degree turn to go into the extruder. Why? On H2S the filament holder is on this side and immediately goes into this hole. One last check before I turn it on. Yes, this is the EU version, because last time the H2S, the first unit, was the US version, which wouldn't be too healthy on 230 watts in Europe. Oh, quite loud. Easiest way to add to the application is to scan the QR code connected with my TechFun. And also automatic calibration, and the total time will be 26 minutes. But this is very loud. I can insert the filament and it's ready for printing. In the meantime, it offered a firmware update. I hope in new firmware we can reduce the beep sound. The firmware is updated to the latest version. I already cleaned the bed with isopropyl alcohol. I will insert these 4 Bambu Lab PLA filaments, but not only the color is different, but also the filament type. All 4 filaments are recognized correctly. And if I want to record a time-lapse video too, then I have to insert here the USB drive. Too loud. It's a tricky, it places the Benchy closer to the aux fan for better part cooling. I'm printing behind closed doors. It is louder a little bit compared to the H2S, and I still couldn't figure out where the hot air goes out, so let's check if you can see something with the thermal camera. Right side. Left side, and this is the back side. So maybe this is the main exit for that hot air, not only for the electronics. In the meantime, I got the answer from the Bambu Lab. The air input is from the bottom, but there is no output fan, so the exhaust is passive, pushed out through the purge opening and the ventilation holes. 3 more minutes. The progress is nice even behind closed doors. But I still think this is some kind of small cheating, placing it closer to the aux fan, because sometimes we don't have this possibility. Bed adhesion check. Strong, okay. I'll wait until it cools down. The bed is 40 degrees. Okay. Even if it is a fast Benchy, the quality is perfect and I cannot even see the whole line. Interesting. There are a few more useful things here, like this scraper, and we have a single and multicolor version. And look at this for the PLA, not only that it is an option to open the doors, but it is currently the error. It tells me to close the door, and now everything is fine. Off topic, but I noticed on H2S it's better to use the top vent doors compared to the open front door. More cooling for the part because most of the air goes over the printed objects. Interesting method. The first object is printed without purge tower, printed by object, but the other two are printed by layers. But this ventilation is really a mystery for me. The temperature inside went up to 37 degrees Celsius, which starts to be too much for the PLA. But the bed is only 55, so if I set, I don't know, 65 on the bed, this will be even higher. To see the picture from the camera on my computer, I have to go LAN only and enable this. I really like these LED lights from two sides, because the camera is in the middle. It's finished. Removing all the supports is super easy. I can see a few more useful things here. I want to print a screw gauge. Color combination is good, light and dark. This is already a third layer, 40 more minutes of printing. It's finishing the numbers. A useful thing between the sample files would be a poop chute. Numbers are very readable. For example, this is M6 and the length is 20 mm. And another useful thing is outer diameter gauge. This will be a very quick printing. It will be finished in 10 minutes. This looks nice too. When I was printing this from glowing dark filament, I can see it's still not perfect. I have few attempts. But with this I can measure the radius, but not in this case because it's too big. But for example, this is 20 mm. It's time for own color printing. I uploaded my image to the ChatGPT and asked to generate a rendered pop figure. Next step, I uploaded that picture to the STL body, and with the image to 3D option I got this STL file. Importing it to Bambu Studio, I colored it using 4 colors. It's not complicated, just time consuming. For this work I needed approximately half hours. And this is the final result, and since the waste material will be the same, I am printing 3 at once. But even then I will have more waste material compared to the weight of the object. 3D printing time will be more than 11 hours. This will be a long one, 10 more hours of printing. This means most of the printing will be finished overnight without my supervision. Printing is at 46%, 6 more hours, but it's midnight here, so the rest will be printed overnight. Good morning, finished in 11 hours and 19 minutes. It's funny to see how supports are coming off already. It looks okay, supports are removable, only the first time I can see this line. This means the purge amount from the black to this beige color was not enough. Weight of the objects, 87 grams. And all the waste material, 135 grams, and I'm not including here the support material. I already mentioned several times that I hate to promote this kind of material waste printings, but there are cases where it is useful, printing smaller objects or when the color change is only in few layers. And I'm very curious about their X1C. That's a system which will exchange the hot end and have zero waste. This is the poop chute for my P1P, and I can see it is compatible and it don't covers any ventilation holes. Only if you are printing high-temp filaments too, print this from the PETG, in that case that poop will not stick to it. Few more parts from the PLA. I have to finish these Labubu pen holders. I want to record some time-lapse, so I will insert this 32GB USB drive, and it is very practical because it is small, it don't stick out too much. And also I want to print something from this silk PLA. It is cardboard spool and don't have hardened edges, so I'm placing a ring around it. This is the recorded Full HD time-lapse. Only in X-axis it's a little bit shorter, otherwise it will record too much from the environment. About these rings, you know what is the best material for them? TPU. Because I noticed that these spools don't have constant diameters, and if it is a little bit bigger and I try to force the rings, it will break. This is PLA, but similar with the PETG. And TPU, for example, this one, TPU for the AMS, is a harder one, but flexible enough so I can place it on this size of the spools. So let's print some more in the blue color. Additionally, we can print very fast with it. Sometimes it is hard to remove it from the texture PI plate, but slowly it will always come off. Instead of the bed level test, I have to print 40 objects and I will spread them on the build surface. Material is PLA silk and it's time to test these O-rings. Surface is cleaned with isopropyl alcohol. For 40 pieces I need more than 1 kilogram, and theoretically it could refill automatically because these are same filaments, but these are dual color filaments and I don't want the color to be twisted if it reloads, so I try to avoid that. I wanted to print 20 at once, but I calculated I want to print 2 groups from one spool, so that's why I'm printing only 15. But anyway, this first layer is perfect like on all Bambu Lab printers, and this will be 13 hours printing. First layer is finished and I can close the door now. Another advantage of the screen, let's say you notice that there is any problem with one object, you can quickly react, and here you can skip that object so it will not kick off others. Error message, AMS motor overheated, so it detected a tangle. On the right side, the filament stuck into that groove somehow. It's too deep there. Interesting rolling. For my luck, this happens only once, but I don't like these cardboard spools, they are quite deformed in this case. You can see the wobbling of the filament. Finished overnight, printing time 13 hours. The second group is finished too, 12 pieces this time, and only one I had a problem with this filament on this printer. I'm short on time, so the second filament I inserted into H2S. First into AMS2 Pro unit, but 3 times I had that filament jam. And now it is on external spool holder, now it is okay, but the Eastern should definitely rating the quality of their cardboard spools. And just another small interesting thing, this ventilation works better on H2S. Here the temperature inside is 32 degrees Celsius, until on P2S it is around 37. Let's move to more technical filaments. PPA-CF. I don't really need anything from this filament currently, so I will not dry it, but let's see how brittle is this filament. Start angle 30 degrees. Around 80. Later I will try a more brittle filament. Now I understand their imagination that with this we don't have to take out this Teflon tube if we want to switch between the AMS and external spool holder. But this will result really a lot of friction, especially with those carbon fiber filaments. I can already feel the friction, here you can even see it, but the filament is only there, so it requires one more 180-degree turn. It's almost impossible to push it here and to enter into the extruder, so at the end I had to take out this Teflon tube, which was their goal, so don't have to take it out. But for this I think I need 2 hands. Oh, look at that. Now I can feel that it is near the extruder. And the second concern is, will it break this brittle filament during the auto leveling? Okay, I can see the filament is extruded on the other side, but this is too loud. And it's not only me who is telling that it is too loud, but she told me that too. Sticky filament, it couldn't really clean the nozzle. All these are removed manually from the nozzle 2 times. It is doing the leveling on the whole build surface, and then I noticed this, and this is the information that this is the first time I'm printing on higher bed temperatures, so that's why it is analyzing the whole build surface. But at least it will be a good test for this filament, because it will have quite big bending. This is the biggest bending. It's just open and wrench for the fun, and this will be quite fast printing. It was finished without any problems, but I wait until bed cools down. It is unloaded from the extruder, but even now I can feel quite a lot of friction inside the Teflon tube. And now our very brittle filament, PPA-CF, but this is the strongest filament type you can print on this printer. I don't really need anything from this filament, so I will not dry it, but let's see how brittle is it. I think it should break around 70. Yes. PPA-CF selected, let's try to load it. But I'm pushing the filament from this side. Okay, one more time. I'm pushing the filament from this side and I remove the Teflon tube temporarily, and I can feel that it is loaded. The filament is loaded, I can see it's extruding. It started, so looks like it handles better those brittle filaments compared to the H2S. Looks completely fine and it will be finished in 10 minutes. Beautiful printing. This is carbon fiber ASA. I have the review in the progress and this is the most brittle filament I ever tested. And if the P2S can print with this filament, then this is not an issue for this printer. Start angle 25 degrees. Around 60-65. I can feel that the filament is extruded. And I can see it is purged already. It started, so definitely this printer handles good these brittle filaments, just like X1 carbon. And this is another open-end wrench. Maybe I should do a comparison between these materials. Now I can feel the typical smell of the ASA, so the sealing is not perfect, but that's okay. But that's why that ventilation hole would be important for me, like on X1 carbon. It is connected to the ventilation hole on the wall, and I just set the chamber fan to 10% and I don't have any smell exit from the printer. I have the feeling that the nozzle cleaning is not really the best on this printer. Pity that with the PET-CF I printed a smaller one, otherwise I could create a nice short video to see which will break on highest torque. Conclusions. I really like this printer, but I know from statistics that viewers are always more curious about things which I didn't like. First of all, I hate that beep noise, it is too loud. And also I don't like the Teflon tube ribs against the top glass, so probably a riser is coming to this printer too. About printing PLA. It is nice that it is designed to print with closed doors, but the temperature which I measure inside is 5 degrees higher compared to the H2S ventilation system. So it is fine in this case, but there are some overhangs which requires a little bit lower temperature, for example. About printing technical filaments. It is good that it can handle even the most brittle filament I ever tested, just like X1 carbon. So in this case it is better than the H2S. There is a solution for the H2S, but more about it maybe in a separate video. But this external spool holder don't have really much sense. I understand that they want that we don't have to remove the Teflon tube theoretically from the AMS, but since the friction is so big, I have to take it out anyway. But if I take it out, then rather I would like to see a spool holder on the left side. In that case, we have less bending of the filament and less friction. The extruder is quite strong, so it can pull the filament without any problems, but it is always better to have less friction. About this ventilation system, I'm missing a lot that ventilation hole because I already mentioned that this is important for me if I print a lot of ABS ASA filaments. I connect it to the ventilation hole and I enable the chamber fan to 10% and then I don't have any smell coming to the room. Here we have to rely on that filter, but as I mentioned, I can always feel that smell of the ABS and ASA. Okay, this was my first experience with P2S and I hope you will have some other experience and write me your answers down in the comment section. And of course the biggest advantage of this printer is the price, but because of that ventilation system I still prefer using my X1 carbon. Who knows, maybe with X2 carbon we will see ventilation hole, higher printing temperatures and maybe even active heated chamber. Thank you for watching this video until the end and happy printing!